In the early 1900s, cars were just being invented. And even in factories, a single car would take over 12 hours to make. Until this guy, Henry Ford, developed and improved a system of working called an assembly line. Now the car was basically on a big conveyor belt and was quickly moved to other workers to complete their part of the build. This allowed them to produce a car in only 93 minutes. One idea or strategy saved tons of time and allowed them to be even more successful. Math can be a lot like that. Once we know a special strategy, we can make things that used to take a lot of time and make them quick and easy, which is why today we're learning about cross-simplifying. Stay tuned. Hey guys, it's Mr. D with you again, this time to talk about cross-simplifying. So, what is that? Well, cross-simplifying is something you can do when you're multiplying fractions. The reason it's a good idea to do is because it keeps you from having to multiply or simplify large numbers. For instance, let's say you had to multiply 16 over 21 and 7/8. Now, if you didn't cross-simplify here, you'd have to multiply straight across, and you'd be doing 16 times 7 and 21 times 8 just to get your first answer, which, by the way, is 112 over 168. And then you'd have to simplify. If you cross-simplify, though, you can make this long, difficult problem much quicker and much easier. But before I show you how to do that, I need you to know that you won't always be able to use cross-simplifying for fraction multiplication problems, just like you can't always simplify a regular fraction. But many times it can be done, and it's a huge help in solving fraction or mixed number multiplication problems more easily. So, here's how you do it. Let's look back at that first problem. To cross-simplify, you need to look at the fractions that are diagonal from one another and then simplify them. So in this instance, look at the diagonal pairs. Start by looking at 16 and 8 together. Now, do 16 and 8 share a common factor? Meaning, are they part of the same multiplication family? You bet. Now, what's their greatest common factor? In other words, what's the largest number that they're both in that multiplication family? In this case, it'd be 8. Now, you could say that 1 and 2 and 4 are common factors as well, and they are, but you need to pick the greatest common factor to save yourself from doing more work at the end. You see, if you fully cross-simplify before you multiply, you won't have to simplify at all when you're done. If you don't use the greatest common factor here, you'll still have to simplify your fraction at the end, so using the greatest common factor really does save you a step. Okay, now since 16 and 8 are part of the times 8s, we'll divide them by that number. 16 divided by 8 is 2, and 8 divided by 8 is 1. Now we'll do the same thing with the other diagonal pair, 21 and 7. Do 21 and 7 share a common factor besides 1? Yes, because they're both part of the times what? The times 7s. So we'll divide them each by 7. 21 divided by 7 is 3. And 7 divided by 7 is 1. Now look what we have. Instead of 16 times 7 and 21 times 8, we're doing 2 times 1 and 3 times 1. How about that? Now we can multiply straight across, and we've got 2 over 3 for our final answer. And of course, it's already in simplest form because we cross-simplified as far as we could beforehand. Sometimes you can cross-simplify both sets of diagonals, like this one. Sometimes it's just one set of diagonals, and sometimes you can't cross-simplify at all. But by learning this skill, you can zip right through those mixed number or fraction multiplication problems. Now let's practice a few. Time to go to the whiteboard. Just as a reminder before we get started, if you want to solve these problems on your own, go ahead and pause the video here and give them a go. Then we'll do the answers together. For the first one, we have 5/6 times 3/7. You could certainly multiply straight across, which is 15 over 42. And then you'd need to simplify, which isn't quite that easy. You'd have to figure out that each side can be divided by 3, and then divide each number by 3 to get a total of 5 over 14. But look at cross-simplifying. If I look at the diagonal pairs, I can see that 5 and 7 do not have a common factor, which just means I can't change those numbers, and that's okay. But if I look at the 6 and 3, I can see that they have a greatest common factor of 3. So I can divide each of those numbers by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. Now I can multiply straight across and do 5 times 1, which is 5, and 2 times 7, which is 14, and boom, there's your final answer. Let's do the next problem. For this one, we can look at the diagonal pairs and see that 4 and 12 can be simplified because I can divide each of those numbers by 4. So I'll turn the 4 into a 1 and the 12 into a 3. I can't simplify the other diagonal pair because they don't have a common factor besides 1. So now if I multiply straight across, I'll get 1 times 11, which is 11, and 7 times 3, which is 21. If I'd multiplied straight across without cross-simplifying, I'd have gotten 44 over 84, which I'd then have to simplify. So are you seeing how helpful cross-simplifying is? Now look at our last problem. Take a look at the diagonal pairs. 14 and 35. Can that be simplified? Do they share a common factor? Yes, they're both part of the times 7s. So let's divide each by 7. 14 divided by 7 is 2, and 35 divided by 7 is 5. Now look at the other diagonal pair, 9 and 36. Those are both part of the times 9s. So we'll divide them once again, but this time by 9. 9 divided by 9 is 1, and 36 divided by 9 is 4. Multiply straight across now, and we have 1 times 5, which is 5, and 2 times 4, which is 8. And I know I'm already simplified because I cross-simplified as far as I could before I multiplied straight across. So that's cross-simplifying, and now you're ready to tackle multiplying fraction problems quickly and effectively. For more math lessons like this, click the links that you see on the screen here, and make sure you press that subscribe button. Until next time, I'm Mr. D. Thanks for joining me.